So let's talk about some functions which are useful. I mean, of course, there are many of them, but let's start, okay, with some of them. Okay, so the first one that we'll talk about is a factorial function. So if you want to actually calculate the factorial of some number, you can actually use the factorial function. Like for example, factorial 5. If you want to see what is the result of this, you can actually just run it. Okay, and if you just run this line, okay, you'll see the result over here, okay, in the console. Is that fine? Okay, so you can also, let's say for example, if you want to figure out what are the number of ways in which you can select a team of 5 from the set of 10 people in the class. Okay, so number of ways to select a team of 5, okay, from 10. Okay, then you can use the choose function. Okay, so choose 10 5 will give you the number of ways. Let's run this. Okay, you can see that that number is 252. Is that fine? Okay, so suppose you want to toss a fair coin, okay, using R. So toss a coin. Okay, then what you can do is basically you can figure out how many times you want to toss it. Okay, and okay, so let's use, there is something called sample command. You can use sample command to toss the fair coin. Okay, so let's see. So if you want some help regarding any of the functions, you can also put question sample. Okay, let's run this. So you can see, you'll get some documentation over here that you can actually see, and of course read, and again just use based on the instructions that are given on the page. Like for example, if you see over here, X is basically from where you're going to choose. Okay, size is the number of items that you want to choose. Okay, and replace means whether you want to do this with replacement or without replacement. So basically, all this is the information which is given to you by default. The replacement replace is equal to false. Okay, so let's just toss a coin once for an example's sake. Okay, so I'm going to choose from, okay, let's just create a coin. Okay, coin is heads and tails. It has two faces, heads and tails. Okay, and now so basically I'm going to choose from one of the two faces of the coin. Okay, coin. Okay, so that's going to be my input to the sample. Okay, and then of course I'm going to just toss this coin one time. Okay, so size is 1. Okay, and well, I don't need to put the replace thing. Okay, let's just run this because it's just once, right? So with or without replacement doesn't matter. Okay, you can see the result is tails. Of course, if you're going to run this again, the result might be different. You can just, okay, is that fine? So this is how you can toss a coin, okay, in R. Is that fine? Okay, okay, so suppose you want to toss 10 times. Okay, so you can actually do this 10, and just set replace equal to true, because if you're tossing a fair coin, if you're tossing a coin with two faces 10 times, then you have to set replace equal to true, because otherwise you cannot do it more than 2 times. Okay, because it's just going to draw from that set once, and then the second observation will be exactly what you didn't see in the first one. Okay, so just set replace equal to true. Okay, and let's run this. Okay, you can see the results. Okay, so these are the results of 10 tosses of a fair coin. Okay. Of course, you can also make this coin biased. Okay, so let's toss a biased coin. Biased coin 10 times. Okay, and let's collect the sample. Okay, so I'll just copy paste this. Okay, and also add prob equal to, so I have to specify exactly what is the probability with which you want heads and what is the probability with which you want tails. Okay, so of course, let's say I want heads with probability 0.8, tails with probability 0.2. Okay, now let's run this. Okay, so you have to put it in exactly this order in which it's there in the coin. Okay, so first is heads and then it's tails. So if you want heads with probability 0.8, so put 0.8 first and then put 0.2. Okay, and let's run this. Okay, you can see this is the result. So it turns out that here we have exactly 8 heads in 10 tosses, but it's obviously, it's also possible that you might get something else. Okay, you can see, for example, in this one you only have one tails. Okay, is that fine? Okay, yes.
Can you just repeat the meaning of replace is equals to?
So it's with replacement. Okay, sampling with replacement. Yeah, is that fine? Any questions? Okay. Okay, so suppose I toss this particular coin 10,000 times and I want to figure out what is going to be my proportion of heads in these 10,000 tosses of a fair coin. So what do you think? What number do you expect to get? I mean, in the biased coin, so its probability of heads is 0.8. So if I toss this coin, let's say 10,000 times, okay, and I'm interested in, okay, what is the proportion of heads in 10,000 tosses of a fair of a coin which gives you heads with probability 0.8. So what do you think? What will be the proportion of heads that you can expect roughly? Roughly point. Okay, so let's quickly check that. Okay, let's quickly check that. So what I'll do is of course I'll not print out the result. Okay, I'll not print it out. Okay, I'll just sample this 10,000 times. Okay, and I'm going to check when is the result equal to heads. Okay, and take the mean of it. So this equal to heads will give me a vector of booleans. Okay, so it's just going to give me like trues and falses. Okay, so trues can be you can read true as 1 and false as 0. So these are like a kind of indicators. So if you have a heads, then it can be read as 1. If it's a tails, it can be read as 0. Or let me just do one thing. Instead of doing this 10,000 times, let me first print out the result for 10 times, and then I'll tell you exactly what's going on. Okay. Okay, so I've just taken this sample and set it equal to heads. Okay, fine. So let's run this. It's going to create a vector of trues and falses. Okay, can you see this? So that means, first 4 were heads, then there was a tails, then 2 heads, then tails, and then two heads. Okay, now if, let me just set this toss results. Okay, let me assign them to toss results. Okay, let's run this again and let me print out the toss results. Okay, you can see this is my, of course I did this again, so clearly I got a different outcome. Okay, now what I'm going to do is this, I'll take the mean of these toss results. So what do you think are you going to get? How many trues are there? 1 2 3 4 5 6, right? 6 true. Okay, so if I take the mean of this, what will I get? 0.6, right? Yes or no? So let's take the mean of this and quickly check. You can see it's 0.6. Yes or no? Have you understood this? Okay, so what I'll do now is this, that I'll just change this to 10,000. Okay, put those results in the toss results, variable, and then take the mean of toss results. And I should get what? By law of large numbers, roughly around 0.8. Okay, the reason is because the probability of heads is 0.8. Okay, let's run this and see it's 0.8. Okay, I mean close to 0.8. Of course, it's not never going to be exact. I mean, it's very unlikely to be exactly 0.8, but it's going to be always close to 0.8. Okay, you can run this again and check. You just did 10,000 tosses. Okay, and many times. And in fact, if you just increase the sample size, let's say instead of doing it 10,000 times, let me do it 100,000 times. Okay, sorry, it's just actually thousand times. Okay, so it's even more closer to 0.8. Yes or no? Okay, clear to everyone? Right? This is by law of large numbers. Have you understood this? Okay, clear? Okay.